We're not going to talk about it now, but toward the end of class, we'll talk about that worksheet.
Real quick, I think if you came into the room after you sent the file, we won't be able to see it. I don't see a file.
You don't see it? All right, let me send it again.
I'm here.
Everyone who's here now. Thank you. It's also, you guys, it's also on Canvas in week 9. And I'm also going to post it again in the homework I'm going to give you for after spring break. I'll post it in a homework assignment too. And so we're not going to talk about it till the end of what we're doing right now. So I'm going to share my screen, which I think. So I'm just going to remind you where we're at. So on Monday, we talked about circles in general, what a circle was. And we talked about the distance formula and the equation of a circle. Yeah. And so the slide that I'm showing you right now is the last thing we did on Monday. That was the last slide we had on Monday. So we're gonna give you guys a couple of problems on the distance formula, just finding the distance between 2 points. Okay, so we're gonna talk about a special circle called the unit circle. So this is a circle that we talk about in mathematics all the time. And it's a circle that's centered at the origin, and that's the point 0, 0, and it has radius 1. So it looks like that. So that's called the unit circle. Unit means 1, radius 1, and it's always centered at the origin because it just makes the math really easy. And so this is what we love in trigonometry. We love the unit circle, and we use it for everything. And in calculus and everything you'll do with calculus, they talk about the unit circle all the time. So if there's a point on that unit circle, a point xy, then we've done this before when we've done points in the plane with coordinates xy. If it's on the terminal side of an angle and that point, that r is 1, right? Remember r was the square root of x squared plus y squared. We learned that when we learned the first definitions of trig functions. We learned the x, y, r definitions. So if we square both sides of that, we get this equation. We get x squared plus y squared equals 1. And that's the equation of the unit circle. X squared plus y squared equals 1. So every point on the unit circle has to satisfy that equation. And another way to write that would be x minus 0 squared plus y minus 0 squared equals 1. And so that shows us, oh yeah, it reminds us, oh yeah, the center is the point 0, 0. And that's how we write, the equation of a circle centered at a point. So on Monday, we were using, I think, the letters H and K for the center of a circle. So now H and K are both 0, so we can just write x squared plus y squared equals 1. So let's see, what I'm going to do is just talk about a couple of points on that circle. So I've just labeled a point at the top of the circle. The coordinates are 2 question marks, and then another point on the positive x-axis. And so what are these coordinates of these points? Well, the radius of the circle is 1. So we know, oops, and I'm labeling all 4 of those circles. So we know the one on the x-axis, on the positive x-axis, we know that the y coordinate has to be 0 because it's lying on the x-axis. And we know that x squared plus 0 squared has to be 1. So x squared is 1. Well, if x squared is 1, then x is either positive or negative 1, right? So there's actually 2 points that satisfy that equation. There's one on the positive x-axis, and then there's one on the negative, the negative x-axis. So I just labeled 2 points. I've got -1, 0, and +1, 0. They're both on the unit circle. The radius is 1, so it's really easy to get these coordinates. And then the upper and lower ones, the ones on the y-axis, we know that if a point is on the y-axis, then the x-coordinate has to be 0, right? So we put in 0 for x into the equation, we get 0 squared plus y squared equals 1. So y squared is 1, which means y is plus or minus 1. So those points are easy to fill in. So I filled in 4 points on my unit circle. So now we're going to look at what some other points look like on the unit circle, and you'll have like 1 or 2 homework exercises like this. So is this point on the unit circle? The coordinates of the point are -1/2 and +√3/2. So how do we decide whether that point is on the unit circle? So is this point on the unit circle? I feel like I hear a parade outside. It's so weird. Nobody's supposed to be out having a parade. Okay. So how do we figure it out? What we have to do is we just have to plug in those coordinates and see if they make the equation true. So we plug in -1/2 for x, and we plug in √3/2 for y. And then we say, is that going to be equal to 1? Because x squared plus y squared equals 1. If it's on the unit circle, that has to be 1. So when we square -1/2, we get +1/4. And if you square √3/2, you get +3/4. And it looks like that equation is true. 1/4 plus 3/4 should be a whole pizza, right? So that means that point that I gave you, -1/2 √3/2, that lies on that unit circle. And so you'll have 1 or 2 questions on your homework where you have to do that, where you have to check whether a certain point lies on the unit circle. All right, any questions about this circle yet? Now let me see. If you raise your hands, I should be able to see you. If you use the raise hand feature. Okay. All right. So what are we going to do with this unit circle? We're going to be using it for the rest of our lives. So I'm going to remind you about radians, what a radian was. We learned about it, I don't know, before last week or before the lockdown. I don't remember when we learned about it, but I'll just remind you what a radian is. So if we have any circle of radius r, and then we make an angle, a central angle. So yeah, I made a central angle, and now we look at this part of the circle that the angle cuts off, and it has length L. So there's a central angle in the circle, and it chops off a piece of the circle, and I made it green, the piece of the circle, and the length is L. So if theta is t radians, t is some real number, then t radians is equal to the length L divided by the radius r. So the measure of that angle in radians is always just the ratio of the length of the circle that it chops off divided by the radius. So that's how we define radian measure. And in particular, if it's equal to 1 radian, if that angle is equal to 1 radian, then that means the ratio L over R has to be 1. And if L over R is 1, that means L and R are the same length. So that's why we like radians. It makes our lives simple. If you have an angle in the middle of a circle and it chops off a piece of the circle that is the same length as the radius, then we call that angle 1 radian. So imagine opening and closing an angle and then opening it just far enough that you get a piece of the circle that's the same length as your radius, and you stop and you go, okay, there's 1 radian. So it also means, and the reason we like it so much is because if we have a unit circle, if our radius is actually 1, so that definition of a radian works for any circle, right? The radius can be anything. But in particular, if the radius is 1, then L over R, L over R is L over 1. So T is equal to L over 1, which means T is equal to L. So the angle is the same as the length of the circle that the angle chopped off, which seems weird to most people. So the measure of that angle is the same as the length of a piece of string, right? That's kind of weird. So that works if the radius is 1, then we know that the radian measure of the angle that we're using is going to be the same as the length of the arc that it chops off. It's super, super useful in trigonometry because we don't have to worry about R anymore. R is insignificant because we just make it 1 and our lives are simple. All right. So we're not going to do a whole lot. Let's see, where am I? So I'm going to have to change slides in a second. All right, I'm being told to go slower. I just noticed that. Okay. Do I need to go back a slide, Nate? Should I go back? Give me a thumbs up or thumbs down.
Yes, if you could, but you don't have to do it on this one. If you can do it on the next one.
What do you mean do what on the next one?
I'm almost done writing this slide. I just didn't get done writing the last slide.
Oh, I see.
For this.
All right, let me just wait till everyone's done with this slide and then I'll go back. Sorry, I didn't notice your little go slower thing. All right, I'm going to go back 1 slide because if Nate needed me to go back, probably somebody else did too. I am so looking forward to spring break.
Amen.
You good? Oh, Carissa, you have a question. I'm unmuting you. What's your question, Carissa?
So the last slide, would you explain the very last slide, because I didn't really understand it in a previous slide.
Okay, it's hard for me to understand your question because you're kind of breaking up. Can you type your question in the chat window?
Yes.
Yeah, type your question in the chat window. And then, Nate, are you good on this slide?
Yes.
I'm going to move forward because I think Carissa might have been asking about this slide. I'm not sure. Yeah, this one, Carissa?
Yeah. The very last part where you said, but also if we only use a circle, I didn't really understand this part. So can you explain it again, please?
Okay, so if you look up above that, I'm gonna circle something while I'm talking about it. If you look up above, we said that the measure of the angle, t radians, is this ratio. It's the length of the green piece of circle divided by the radius r. But if the radius r is 1, then we get this equation way at the bottom. I'm circling it in purple. We get the radian measure of the angle is the piece of the circle, the green piece of the circle, divided by 1, and because r is 1. And so L over 1 is just L, and we get this nice little equation. So it's because of the ratio. The number of radians in the angle is the same as the L over R. But if R is 1, then it's just L. Does that help?
Mm-hmm.
We'll talk again later. It's something that you won't need to use right now, but we'll work with that ratio again later. But the point is, if we have a unit circle, then any central angle will always have the same measurement as the length of the arc that it chops off. And so we're always going to use that fact in this class. Let me see if there's any other questions. Okay. Nate, I'm going to put your hand down. How do I do that? Oh, here we go. Clear all, I guess. Okay. All right. So I'm going to change slides. So we're going to use the unit circle to do some new definitions. So where did it go? Here we go. So now we're going to talk about circular functions. Now, when we come back from spring break, we've never defined a function in general. So when we come back from spring break, we're going to talk about what does it mean, function, what is that? But right now, we know what trig functions are. They're cosine, sine, tangent, cotangent, cosecant, and secant. Those are called trig functions. So we've had several definitions. We've had 2, actually. So what we learned in chapter 2 was chapter 2 was the right triangle definitions. And so you guys don't need to write these down. You already know these, I think. We used right triangle definitions. The cosine is the adjacent side over hypotenuse. The sine is the opposite side over hypotenuse. Tangent was opposite over adjacent, and etc. These are things that we've been using in chapter 2, all of our right triangle trigonometry definitions. But even before that, in chapter 1, we had another definition. Before we even learned about right triangles, we had the XYR definitions. And those were good for any angle. The right triangle definitions were only good for acute angles, but the XYR definitions we could use for anything. So remember how we did those? We said take a point on the terminal side of the angle, and then you can define R to be that distance from the origin to that point, and that's the square root of x squared plus y squared. And then we said, oh, okay, cosine is x over r, sine is y over r, tan is y over x, etc. Those definitions we learned in chapter 1. So these are things we already know. You've already been using them. You've got them in your notes. You've been tested on them. But now we're going to do a third definition. And this is the third definition is the one that is mostly used in calculus. So the third definition, the book calls it circular function definition. So we're going to use the unit circle in this definition. So take the unit circle and any point on that circle, x, y, and take the point 1, 0. And now the distance along the circle between those 2 points is called t. That's the length of that arc. And so if that point x, y travels around the circle, t will get longer, right? If it goes counterclockwise, t will get bigger. And it'll get all the way to 2 pi, and then it can keep going past 2 pi. It just starts going around and around and around. So, oh, there it is. So what we're going to do is we're going to define our cosine, sine, tangent, cotangent, all those things. Instead of having the input be an angle, we're going to say, oh no, the input is just that length of that arc, because the length of that arc is the same as that angle that makes that arc. So we're going to define the cosine of t to be the cosine of the angle that makes the arc t. So t is the length of circle that gets chopped off by an angle. Well, if the length of the circle is t, then that means the angle that chopped it off has to be t, because that's what's nice about the unit circle. The angle measurement and the arc length itself are the same. So the cosine of t is going to be x over r if we use the chapter 2 definitions. But r is just 1. So it's just x. And that's even nicer than the chapter 1 definitions. Chapter 1, we always had to have x over r, y over r. But now r is just 1. So our lives are easier. So we're going to define the cosine of that arc length to be the same as the cosine of that angle. And the cosine of that angle is just going to be the x coordinate of the point. And then the sine is just the y coordinate. So you take a point on the unit circle and you say, okay, what's the distance from the point 1, 0 to that point? And then you go, what's the cosine of that distance? And then it's just the cosine of the angle. And the sine of that distance is the sine of that angle. Tangent of that distance or that length is just the tangent of the angle. So it's y over x. So these are just like the chapter 1 definitions of trig functions of an angle, but now we're calling them trig functions of a distance, but it's the same thing because we're using the unit circle. And what's nice is the unit circle makes r just 1, so we can just forget about it. All right. And then my other definitions, oh, remember x can't be 0, otherwise tangent won't exist when x is 0. So the other definitions are secant is 1 over x, cosecant is 1 over y, and cotangent is x over y. So these are new definitions that we need to memorize, but we already kind of know them from our work in chapter 1. We just don't have r anymore. We can just ignore it. All right. Any questions about what this definition says? Raise your hand or yell at me. All right, people are still writing, so I'll wait. All right, let me look at your faces. Okay. All right, looks like you're ready for a new slide. Okay. Oops. All right, so here's the handout. It's a picture of the unit circle with a bunch of lines. And what we're going to do, I'm going to get you started, but you're going to print that out and it's going to be part of your homework for when you come back from break. So I'm going to help you get started. So the instructions say label each special angle on the unit circle with its radian measure. And then, without a calculator, label the points on the unit circle with their coordinates. So what it means is, so we already have a couple of points. So we have the point, oops, let me change to red. We have the, oops. We have the point 1, 0 over here on the x-axis. We have the point on the y-axis 0, 1. And then the other one on the x-axis is -1, 0. And the one on the y-axis down below is it's 0, -1. So now what are these other points? So these other points on the unit circle are points on the terminal sides of a bunch of angles that we already know. So the first one, the first little green line in the first quadrant, so I'll draw my arrow for my angle. That's the first special angle that we learned. We learned pi/6, right? So this is what I want you to do. I want you to draw the angles and label them. So, and I want you to do them in radians. Does it say radians? Yeah, it says radian measure, good. So the first one is pi/6. The second one is the blue one. That one should be pi/4, 45 degrees. And then the third one is pi/3. So you don't have to draw all those arrows because that's going to make your worksheet really messy. But what you can do is on the terminal side, write the angle. So I'm going to do one more angle. Let's say the next green one, I'm going to write 2 pi/3. I'm writing it sideways. So I'm writing the angle next to the terminal side of the angle. So what I want you guys to do, and part of your homework, is to fill out the rest of the circle with those angles. Just label them. And you should be able to figure them out because you've already learned those angles. The other thing I want you to do is fill in the coordinates of those points. So remember, the coordinates of those points are now just the cosine and the sine. So for pi/6, and we've memorized those, we should remember the cosine is √3/2 and the sine is 1/2. For pi/4, that's 45 degrees. The sine and the cosine are the same, √2/2, √2/2. So what I want you to do is go around this unit circle and remember, oh, I know the cosine and the sine of that angle. I memorized it. So for this one, it's 1/2 and √3/2. So you've already been, they're just cosines and sines. And those are the X and Y coordinates of those points. Cosine is the X coordinate, sine of the angle is the Y coordinate. So what I want you to do over the break, or you can do it in the next, you can do it in about 10 minutes probably. Fill in all the angles and then put the coordinates of those points around the circle. And you don't have to draw those arrows. That'll just look really messy if you do that. So that's part of your homework. And now I'm going to give you the rest of the homework, and I'm going to post it as a written assignment on Canvas. So I'll post this handout. Is there anybody here who does not have a printer at home? Raise your hand if you do not have a printer, a way to print handouts at home. Because it never occurred to me. Is there anybody, Priscilla, you don't have access to a printer at home? So, Carissa, do you not have a printer at home?
No.
No?
No.
All right, so when you do worksheets, you're gonna have to draw the pictures, right?
Okay.
Okay. All right, I'm sorry about that.
That's fine.
All right, so you're just gonna have to draw your unit circle, 19, and fill in everything in. Okay, all right. If you could borrow one from the college, would you borrow one? If I could.
I mean, I'm fine drawing it as far as it's fine with you.
Oh yeah, I'm okay with it. I just thought
Okay.
if it would make your life easier, I could try to get you one, because they're loaning out equipment, but they didn't list printers because they don't realize math students need printers because we don't write papers, we draw pictures. I can try to get you one. I'll ask if I can get one for you that you can borrow. It might make your life easier to print out my worksheets. Okay.
Okay.
I'll check what I find out. All right, you guys. So here's what your assignment is going to be, and what you're going to do is you're going to have to scan it and upload it as a single PDF, like you did on the test. So use your app on your phone if you don't have a printer that scans. So it's going to be, I haven't posted it on Canvas yet. It's going to be written assignment 7, and it's going to be due the Monday after break. So if I were you, I would do it now before break, because it'll be easy, right? Because you just saw all this stuff and it's fresh in your minds, and it'll be easy if you do it now. But if you wait till Monday or Sunday, a week from now, it might be a hard assignment to do. Carissa, do you still have a question, or did I forget to lower your hand? Do you have a question, Carissa?
Oh, no, I don't have a question.
All right, I'm going to lower your hand. I just forgot to.
Okay.
Okay. So what you're going to do, there's a couple problems in section 1.2. We skipped that section. We didn't talk about circles in chapter 1 because it was too soon to talk about this stuff. So these are problems on the distance formula, I think, and maybe circles in 1.2. So problem 32, 34, 38, 48, and 50. They're not hard. We've done a couple of examples in class. And then I want you to print out, if you can, this unit circle and label all the angles with radians, and then find all the coordinates of those points. And then you'll have it all filled out, and it'll be really beautiful, and you're going to use it as a reference. And you're going to do 2 problems from 3.3. So they're problems 22 and 24. So you're going to have your unit circle, use it as a reference, solve those 2 problems. It's just really simple answering questions. And then you're going to scan all 3 things and upload it to written assignment 7. So I'll post that on Canvas today after I unlock the exam for a couple people. You can get this done before break and then forget about it. It won't take you very long. But like I said, if you wait till break is over, it's not fresh in your mind anymore. It might be hard. So, how was everybody doing? All right, so I am gonna let you guys go on time this time. Are there any questions about what we're doing today, what we just did? Did I hear someone say something?
It was just me, just making sure you didn't kick us out before you opened the test so we can submit it on Canvas.
No, I'm not going to kick anyone out. So let me do it right now while we're talking. So and then I can have you check while we're still talking, and you can make sure you can get in there. So hang on. So everyone else, if you don't have a question, have a really good break. And I hope you get relaxation and fun somehow. If you have questions, just hang out. I'm going to open up the test for a couple people. Is this the right class? Yes. Okay, so you guys, I'm going to give you, since you all did the test and all you have to do is submit it, right? Upload it. I'm going to give you a half an hour to do that. So you need to get it done by 3:46. So I'll tell you when you can do that. Let's do it 3:47. All right. So Nate, Arturo, and Alan. Alan, are you still here? Yeah. Why don't you guys go in right now and make sure you can get into the test while we're sitting here. Go back to Canvas, click on exam 2, remotely proctored, and let's make sure you can get in and start the test again.
All right, it's loading up. I'm just gonna send the file from my phone to my computer.
Gotcha.
Yeah.
Okay. Alan, you doing okay? Arturo, are you still there?
I'm still trying to figure out how to put the PDF together.
Okay. Oh, okay. So which app are you using, Arturo?
Well, at the moment, I'm just using it off my computer. I'm trying to figure out an app because I know you can do it from Adobe.
Well, I found a good app. Well, I thought it was a good app. It was one of the top one. It's called Genius Scan. But I'm looking at it right now and what it looks like on the app versus what it looks like on my computer right now. Every page it's not blank, but it's really it's like you can see most of the stuff written, but a couple pages look, they're not, you can tell there's stuff written on them, but they look kind of blank. So I'm gonna try to rescan my page.
That's why I think from what I see at the moment, the best one is
because
Adobe,
it came out looking like that.
Ooh.
Yeah. Open your email. Okay. You sent me an email, not a Canvas message.
Yeah, this is the exact same email I sent myself, and this is what some of it looks like that, and then but a lot of it looks pretty much like that one did. There's stuff, I can see stuff written on this one. My camera won't get that close, but it's that page, but you can, like, some of these pages are, yeah. It came out really, the scan came out pretty bad. So I guess I need to
try it again.
I mean, yeah, I have it all right here. I just need to rescan it. That's what took me along, because I had to rewrite everything. My printer decided to hit the crapper, I guess.
And I don't see an email from you either, by the way. So you didn't.
Oh, I sent it. Oh, that's weird. I have a draft.
It's not in my email, and it's not in my. Maybe it's buried in Canvas. No, it's not in Canvas.
Yeah. I sent it from my Outlook.
Yeah, it didn't arrive in my Outlook. Let me look for your name, but I just wanted to look at the scan that you sent me.
This one, scan this time.
Yeah, I don't have an email from you at all. I have one from March.
Oh.
Okay, it's all right. So, do you need more time? Are you trying to download another app?
No, I'm just rescanning these ones one more time to see what it looks like on this same app before I download another app, I guess. Okay. Because I thought it was the pictures look really good. I just don't know why it came out like that.
So, Alan, how are you doing?
Right now, I'm just going back to the exam to resend the exam,
okay,
or at least the scan.
So you're going to upload it. Do you have it saved as a PDF on your computer?
I'm trying to send it from my computer from my phone, since my phone has the scanner.
Right.
And from the scanner,
right.
I'm trying to just get onto my computer. Sorry.
You have to send it from your phone to your computer, and then use your computer to upload it to the exam, because the exam, you can't open it with your phone. So have you sent it from your phone to your computer yet, Alan?
I'm sending it to my my email.
All right, so send it to yourself and then open it up in your computer, and then open up the Canvas exam and then upload it there from your computer.
Right. Where is email now?
Okay. Hopefully this time. 14 pages.
14 pages? Okay.
Sam 2. Share. I'll just send it in Gmail. I don't know where it went last time.
You're sending it to yourself?
Yes, because I'm gonna check where the Outlook sent, because I hope I didn't send it to like the school or something.
I might have sent it to some other Gomez. There's there's this person that works in the Puma Center named Christina Gomez, and she gets my email.
Oh, she would be on my email list, wouldn't she? Because I go to the Puma.
My email a lot, and she usually forwards it to me if she knows that it was supposed to go to me.
Okay, yeah, that may be it, because I was like, well, you're the only one that I know of, and then like if there's another one working in the Puma Center, then yeah, she might be on my email list, and then she might have just got my email. Whoops.
That's all right. It's a small world.
That makes sense. I was like, what do you mean you didn't get it? I was like, I know I sent it to you.
We all know each other, and she and I, she gets my email more than I get hers, but I get more of hers.
Okay, this one showed up a lot better. Okay. Oh, I use like color codes and everything, so it doesn't even matter anymore.
So you use the app?
No, when I did the test, I utilized colored pens. That way, I just do. That's the same way I did my notes and everything. So it just made me remember like that.
Hang on, Alan, you don't need an access code, Alan.
Yeah, I just noticed that I don't actually need it when I saw.
Okay, I have to unplug my monitor so I can access the.
All right, bye.
No, I just had to unplug one of the two monitors I have so I can access the test.
I gotcha. All right, so Alan, how you doing? Are you uploading it yet?
Oh, I have to. Okay, I have to
Got
leave
it.
here too. Okay, do I just turn off the camera?
Oh yeah, you have to get off of Zoom. That's right, Alan. We have to get off of Zoom because the camera needs to use the.
You might be able to just turn off your camera and that might work.
No, Proctor.
Oh, just camera.
No, don't turn off your camera, Alan. Shoot.
Nope.
Don't turn it off. I'm gonna make you leave the meeting because Proctorio needs your camera. So I want your camera to be on for Proctorio. Or you can maybe mute your video. I don't know, but I'm gonna kick you guys out, and I want you.
Yeah, if you turn off your video and mute your mic, it works. It says my camera's good to go. Yeah, it says my camera's good to go.
Good. So I'm muting your audio, Alan. I want you to mute your video. I'm muting everybody.